SSI meetup. Today we have Daniel Paramo and Anthony running with us. They will explain what the Blockcerts standard is. This is something I've been really keen on learning about for a long time because Blockcerts started in a really interesting way, and Daniel and Anthony will be sharing with us everything we need to know about this world, and you will be able to ask questions during the presentation also to find out how this stuff works. We're just going to quickly review in the next slide what SSI Meetup is about. So basically what we're trying to do at SSI Meetup is to make it easy for everyone in the world to learn about SSI, and it's open for everyone, for companies, for individuals, for associations, whatever you want, because all the material that is being created here is shared with the Creative Commons by share alike license, which basically means you can reuse the material in whatever way you want. You just need to give credit back to the person that created it, which today is Daniel and Anthony. And also please give credit back to SSI Meetup. As you know, if it's the first time for you, you might not know, we've done plenty of different SSI meetups before. This is like a little bit of the history of SSI that has been going on for 18 months. And we'll just continue doing that. We have like 3 to 4 webinars that we record a month, and you get the Google Slides, the video, and the SlideShare link where you can use this material, and people around the world are using this and organizing SSI meetups. If you have any questions, please interrupt at any point of time. You have a question tool that you can use. I'll share those questions with Anthony and Daniel, and then just I'll share them during the presentation or at the end of the presentation, depending on how it fits. Okay, and I think that's about it. Daniel and Anthony, thank you so much for joining us today.
Thank you, Alex, for that introduction. I appreciate inviting us for this webinar for sure. So hello, everybody. It's my pleasure to be here next to Anthony, giving this amazing webinar about Blockcerts. A little bit about myself. I am a helicopter geek who worked as a helicopter test flight engineer for a few years, then moved to do helicopter business development for Latin America. I found myself in the blockchain space, in 2016, which 2 years later took me to work for Learning Machine as a biz dev executive in 2018, 2019. And here's where I learned about Blockcerts, open standards, W3C, DIDs, verifiable credentials, and their benefits. I am also the co-founder of a company called Swys, which is a fintech B2B SaaS startup, driving business growth by turning actions into payments, while also generating business growth by representing companies in the US and Latin America with eco-intelligence solutions. And I am also an advisor at Xertify, which is a SaaS startup creating certified network for institution certificates using different self-sovereign identity solutions like Blockcerts. That's a little bit about myself. Next, please, Anthony, go ahead.
Thanks, Daniel. Yeah, so my name is Anthony Ronning. I'm an engineer at Learning Machine, started in early 2018. I work primarily in the backend here, and now lead maintainer for Blockcerts. I'm also advising a company called Truckle that is a supply chain company that issues Blockcerts as well. They issue them for drivers. Besides working on digital credentials and identity solutions, I'm very passionate about Bitcoin and second layer solutions such as the Lightning Network. I build dApps here and there as a hobby, and that's pretty much it. That's me.
Perfect. Thank you, Anthony, for that. So let's begin. Blockcerts is an open standard for creating, issuing, viewing, and verifying blockchain-based credentials. This may include certificates for civil records, academic credentials, professional licenses, workforce development, and more. These digital records are registered on a blockchain, cryptographically signed, tamper-proof, and shareable. The initial design was based on a prototype development by the MIT Media Lab and by Learning Machine. Blockcerts consists of open source libraries, tools, and mobile apps. Blockcerts uses and encourages consolidation on open standards, is committed to self-sovereign identity of all participants, and enable recipient control of their claims through easy-to-use tools, such as a mobile app, a wallet, that we will cover in this webinar in a little bit. Blockcerts is also committed to availability of credentials with any single point of failures. The goal is to enable a wave of innovation that gives individuals the capacity of possess and share their own official records. Anthony, if you want to go ahead for this one.
Yeah, thanks. So I first wanted to jump right in to the flow. Thanks, Daniel, for giving that background on Blockcerts. First up for the flow, those of you that may have already be in the digital credentials or verifiable credentials industry, some of this will look pretty similar to what you'd expect. But so to first start off, an issuer invites a recipient through some means, and the recipient has to have an open source, the open source Blockcerts wallet or another wallet that that is interoperable with Blockcerts to accept the invite. For the invite itself, it could be like an URL that the issuer shares. It could be a QR code, a button in the email, anything really. The app supports deep linking for various actions, so it's really easy to invoke the Blockcerts wallet as an issuer developer. But during the invitation step in the Blockcerts wallet, the main thing going on here is that the recipient sends the issuer one of their Bitcoin addresses. And this Bitcoin address will later be put into a Blockcert meant for that recipient so that they have a strong claim of ownership over the credential. The mobile app, the Blockcerts mobile app functions as a BIP32 Bitcoin wallet and creates a new address for each new invitation flow. This is abstracted from the user, of course, but they are given their 24 seed phrase so that they can back up and then recover their addresses, like if they get a new phone. So once the issuer has the recipient's public key, they can start creating a new certificate for that recipient and inserting the public key and any other specific information about the recipient or the credential that they are receiving into the certificate. We have open source tooling to help support the mass creation of similar credentials based on a template. And we also have a lot of other tooling for this entire process as well. All of that's open source. So once the credential is created, it is then hashed and anchored to a blockchain. The blockchain receipt information is then added to the credential, which of course is not included in the hash verification step, because typically when you change a file, you change the hash of the file, right? Blockcerts is a JSON LD file, so we can exclude the blockchain receipt when we're doing anchoring again, so we get the same hash every time, unless of course someone changes the credential itself. This is what really helps separate Blockcerts anchoring from a typical file or PDF anchoring that some other people might do. You need a way to easily add blockchain metadata back into the file without changing its hash. And this also allows for easy verification, since all you need is that single file to do the hash checking and blockchain verification. After the credential has been anchored to the blockchain, so we're at step 4 now, the issuer can send the Blockcert to the recipients. The transport mechanism can be anything again here. It could be URL. They could email the file to them. It could be a deep link here as well. The recipients can also import the Blockcerts file directly from their device too, if they saved it to their device. But after the recipient has received the credential, they can populate it into the Blockcerts app, and they can begin verifying it in the app or sharing it with others as well. We have open source verifiers in our GitHub repository. There's verifiers that community members have also created in different languages or platforms. And people that are not running their own open source verifiers can go to blockcerts.org to drag and drop a Blockcerts file and validate whether or not it is legit. Blockcerts can also be hosted as well. It doesn't have to be. So the recipient has the option of also sharing a URL to the Blockcerts file, which can be the URL. The URL itself can point to a verifier that already has the certificate loaded. So then it's really easy for verifiers to just get the URL, see the certificate already loaded in, and verifying automatically. Next slide, please. So here's some of the UI for some of the verifiers I was talking about. What we have here are some screenshots from blockcerts.org itself. The screen on the left here is from our Blockcerts universal verifier, which has a credential viewer along with information such as verification status, issue date, expiration date if there is one, and some other metadata information that might be relevant. It has some blockchain information as well. On the right here, we have a cool little pop-up that, as you hit the verify button, it'll go through all the steps with you right there live. It'll do its format validation. It'll do the hash comparisons and issuer status check and things like that. Next slide. And on this slide, on this screen, we basically have the same thing, but inside the mobile app. So we have both our Android app and iOS app open sourced. And you can do pretty much the same things you can in these apps as well. You can load in the credential, you can verify it, and it'll do the same steps where it walks through the hash comparisons and things like that. Next slide. So here's some just general technical information, some nice to knows, I guess. Blockcerts is structured as an extension to the Open Badges standard. The file itself is a JSON LD file containing information about the issuer, the recipient receiving the credential, and the achievement or badge, as they like to say in the Open Badges community. But it also includes, of course, like I said, the blockchain information needed to prove its existence and the certificate immutability. When creating a single Blockcerts and issuing it, like I said before, this process, it hashes all of the relevant data inside the JSON file. You create a blockchain transaction with that hash and you transmit that to the blockchain network that you're using. And then boom, there you go. You then issued a Blockcerts, basically. So Daniel, next slide, please. I'm going to go through some visual examples. I hope it's not too technical, but I think it would help kind of really show what's going on here. What we have here, first showing off the like hashing process of Blockcerts. So I have a minimized example of a Blockcerts file here. I hope it's not too hard to read. It has some information about the badge. Of course, and badge in this case is basically the achievement that the recipient is receiving. And then it has, like I said, information about the issuer. It has a URL pointing to the issuer's profile, which I'll talk about in a minute. And then, like I said before, we stick all the recipient public keys inside the certificate. So we have a field here called recipient profile. And if you can see it towards the middle there, we got the public key of this sample recipient here. So all this information, and again, this is just a minimized example, but this is the bulk of the information. All of this is then hashed, and we get what we basically see here on the right, which is this random looking string. So anytime someone, let's say maybe they want to change the name of this recipient, it'll produce a completely different hash that it doesn't look similar at all to what we have here on the right. And if it produces that different hash, then we know that the certificate was altered. And we can just, when we're doing the verification steps, we say that the certificate isn't valid. Next slide, Daniel. So after we do the hashing, so I just wrote hash on the left side of the certificate. So we have the certificate there, we have its hash. What we then want to do is basically anchor that to a blockchain, and Blockcerts is blockchain agnostic. So right now in our open source, we currently have implementations of Bitcoin and Ethereum. So if it's a single certificate we're hashing, we take the certificate hash and we basically write that in the data field of the blockchain transaction. In Bitcoin, it's an op return operation in the script field, and for Ethereum, we just put it in the data field. We don't do any fancy smart contracts or anything like that for Ethereum. It's really just a hash that we broadcast. But yeah, so after you have your blockchain transaction and you sign it and you broadcast it to the network, you'll get a transaction ID. And we basically take that transaction ID and we put it back into the certificate. And in this case, on the left here, you can see we call it anchors. So we have the Bitcoin anchoring information here as the example. So Daniel, if you go to the next slide here, now that we've written this, now that we issued the certificate, we can then basically do the reverse, where we take the certificate file, we find the transaction ID in the anchor field, we look up the blockchain transaction on the blockchain network, and we verify that the data field has the same hash as the hash of the rest of the certificate. So in this case, I just wrote the word hash in there. It's not actually written in the file. I just kind of condensed that down a little bit. So I just assumed, okay, the rest of the file, its hash goes to that value 637E, etc. So as long as we know that the hash information is correct with what is on the blockchain, we're good to go. And we at least verified that the certificate has not been altered since it has been anchored to the blockchain. Daniel, next slide. So after we do that, there's other checks that Blockcerts does to verify several other things besides immutability. We check the issuer of what the certificate says, who actually issued it. So in this case, we're just saying issuer.org issued this credential, but anyone could say that, right? So we need to actually we need to pull up this URL to verify that the issuer has a public key that matches, or the issuer claims they have a public key that matches the same public key that issued the transaction in the first place. So if they didn't, then we can tell, okay, the issuer doesn't claim ownership of any of the public keys that actually issued the transaction. So we're going to say that the issuer did not make this transaction after all. So even though the certificate says that and it was anchored to a blockchain, we do this additional check to make sure that who they say they are actually did the action. But we can also do the revocation checks as well. So basically, it's another URL in the issuer profile that we look up in the issuer profile URL. So we check to see if in the revocation assertions there exists an ID that matches the certificate ID. And if there's not, then then it's all good. The issuer has not revoked the credential. But if there is an ID that matches, so in this case, if that in that example down there, if that ID would have matched the certificate, then we would have displayed back to the verifier, okay, it looks like this certificate has been revoked, and the reason is because, and in this case, it was accidentally issued to the Ethereum network. And I think I go more into revocation later down the line. Next slide, please. So that was basically the flow and some of the checks that we do. Some of the other information about Blockcerts, like I said before, it is blockchain agnostic. It was developed specifically this way. The first implementation was Bitcoin, but we did add Ethereum full support early 2018. All throughout our active repositories in our open source Blockcerts repo, there exists connector files for each implementation of a blockchain. The work for adding additional connectors for additional blockchains depends primarily on the difficulty in developing for a given blockchain. But as long as there's mechanisms for creating a transaction, adding data to it, broadcasting and verifying a transaction, it should be pretty trivial to add it to our Blockcert ecosystem. Outside of our official support for Bitcoin and Ethereum, there has been other community people in the Blockcerts community has added Hyperledger support at one point. I believe this was a closed source project or prototype that a university did, as far as I could tell. But we're always interested in communities adding or this community adding more chains to our official support. So if you are into Hyperledger or anything like that, and you want to use Blockcerts, then feel free to get in touch and see if we can get an implementation merged in. That'd be great. But yeah, next slide, Daniel. So the flow I mentioned earlier was specifically targeting just a single use case of a single certificate being issued. If we were to try to do the same thing for maybe a university that is issuing to a whole graduating class, it wouldn't be very scalable if we had to create a new Bitcoin or Ethereum transaction for every single certificate. Um, you know, Even at a modest like $1 fee per transaction, and we all know Bitcoin can get a lot bigger than that. It could result in a really hefty fee if they're issuing thousands. So Blockcerts takes advantage of the same Merkle tree mechanism used to verify thousands of transactions in a block in a normal blockchain network. Each certificate needing issuances can be hashed together to produce a resulting Merkle tree root hash. So basically at the very top of this photo here on the right, we get one single hash similar to what I showed earlier. And just that hash is written to the blockchain. So in order for each of these Blockcerts at the bottom row here, for each of these to be independently verified without needing the knowledge of every other certificate, the Merkle tree receipt is then written into each Blockcert, and the receipt written to each Blockcert will only include the information needed to verify the single record in a Merkle tree. So, there's two approaches here. You can, if you're just doing a single certificate, you take the hash of that and you just write that directly to the blockchain. But if you're doing, taking advantage of the Merkle trees, you just write the hash, but in this case, you would write the information needed to traverse the tree. So everything in orange here, you would write that information and into the receipt, and verifiers, and of course this is all programmatically happening anyway, so not an individual doesn't do this, but you have enough information from there to get back to the Merkle root if you know the certificate, and then boom, you just prove that through computation that the same hash that the certificate adds up to, in the end, getting the same Merkle tree root. So it's really complicated, and I'm probably not explaining it in the best way. So really just the takeaway here is that you can scale the issuances of Blockcerts through the use of Merkle trees. And again, all of our open source handles this automatically, so there's not like any advanced functionality you need to know here unless you're creating your own issuer for Blockcerts. Next slide, please. So some general information. So one of the things is what data is safe to put in a Blockcert. So generally the purpose of a certificate or credential in the end is really to be able to prove to some entity that maybe you completed some task, or you are authorized to do something, or you are something. It needs to be shared in some way or form. While the data revealed in a transaction contains no PII, the person receiving the certificate might want to share that achievement with someone else. So the data should not contain more information than necessary for the use case of that specific credential. For example, it's okay to say that a person graduated from a single university in a certificate, but you should probably not contain like their home address or other information in that same certificate, because they need to be able to share that with other people. There's a concept known as zero knowledge proofs in this industry that I know other people are working on, and it should be able to help that. One of the cases that everyone talks about is being able to prove that you're over 21 without revealing your age. So on your driver's license, it says what age you are, but really bars just need to know, are you over 21? Zero knowledge proofs are a mechanism to be able to say, I'm over 21. You don't need to know my exact age, but here's like how you can prove that I'm over 21. So there is this mechanism for being able to hide specific information while proving the general information about something else. So this does not, we don't have any support for this in Blockcerts v2, but it should be possible in future iterations of Blockcerts, which I can get into later. Next slide. So earlier I showed some UI, some really cool looking certificates. One of the cool things that Blockcerts currently supports is the ability to add HTML into the certificate. So this HTML is included as part of the hashing process to verify the immutability, like with the rest of the certificate. So if someone, again, were to try to change, in this example, the name Justin Baywater, again, it wouldn't verify, and the display, when it tries to verify, it'll say it's been tampered with. The HTML is completely optional, so you don't have to do that if you don't want to, but it's one of the, I would say, like a bonus feature of it. I know a lot of other credentialing platforms, they, especially digital ones, they don't necessarily have this, a display to them. But while we are transforming into a fully digital age, I believe there's still strong use for having customizable displays to match pretty much what we've been doing with records for centuries. For instance, like maybe a university may have their graduation records that have looked the same for decades. Maybe one that is easily recognizable and distinguishable from other universities. Letting them have full control over the design of their digital certificates is really key for adoption, not just for issuers, but so that recipients can have something digital that has the same appearance, just like their physical record. Visual credentials are something that we all know as a society and something that we're all kind of used to. Right now, this verifiable displays, this HTML stuff is it's supported but not officially standardized in the Blockcerts ecosystem. That's something that I want to standardize for version 3, which I'll get into later, but I also want to maybe open it up for other display types, such as maybe like PDF or PNG or things like that. Next slide, Daniel. And one other thing I wanted to get into, so I mentioned earlier Revocations. Here's an example of not only just a revocation but what the UI displays when there is a failure. Like I said, revocations are part of the verification process. So this will verify that the certificate is still valid and has not been revoked by the issuer. The issuer, has that revocation URL that lists all the credentials that they have revoked. And there could be many reasons for that, such as, they issued it accidentally. The recipient was found out to be a fraud, or they cheated on a test or something. But yeah, so we also support expirations without the need to do these manual revocations. But the whole aspect of revocations and issuer URLs, it should get a big uplift in version 3, which again I'll talk about later. I think that's it for that slide, Daniel. And I think, yeah, you're up.
Perfect. Thank you, Anthony, for that. All right. So what companies are building a solution around Blockcerts? So we have Learning Machine, located in the US. They provide a complete system for institutions to issue and manage official records using Blockcerts. They build this open standard along with the MIT Media Lab. They are the pioneers and leading the way on Blockcerts with various institutions using their system. They recently won a grant from the Department of Home Security, DHS, in response to an open call to develop vendor-neutral technology solutions that prevent the forgery and counterfeiting official records for immigration, travel, visas, and other use cases. This grant will bring various upgrades to Blockcerts. The next one we have Xertify, located in Colombia, Bogotá, is a global technology company that also manages certified credentials and different types of documents anchored to the blockchain using Blockcert. For users, Xertify offers a digital folder where they can store and share, if desired, their certified information. And for institutions, Xertify built a tool that automates document management. Xertify was recently accepted from 100 participants to the first self-sovereign identity incubator called SSI Incubator in San Francisco. The incubator partners with Sovereign and Hard-Yaka, and its goal is to facilitate the creation of SSI-based companies of all kinds. Next, we have OS City. They are located in Mexico and Argentina. Uses the newest technologies to help institutions to leapfrog the digitalization process and go straight to the most secure, portable, and digital documents using Blockcerts. OS City was recently selected as a finalist in the South Summit, and they also They also won a UNICEF Innovation Fund. The fund has been specifically designed to finance early stage companies, open source technology to the potential to impact children on a global scale. And then the last one is Best TR, located in Italy, is a global digital credential system offering different types of digital credentials, like micro-credentials to notarized certificates, and you can manage the issue and verification, conversion, and withdrawal of these digital credentials and the data. They are part of Sinica. Sinica is a non-profit consortium made up of 70 Italian universities, 8 Italian research institutions, and the Italian Ministry of Education. Fuck. All right, so let's think about some use cases. There's a bunch of use cases, but let's here I'm just gonna touch base of a small summary of some of them, and in the next slide there's a map with more details I'll share with you guys. All right, so let's start with the Ministry of Education and Employment in Malta. Malta is the first nation state to implement Blockcerts across their education providers to facilitate the transition from a student to applying for a job. Various types of training academies, programs across Malta, like higher education, skills training, and K-12, are issuing records of achievement as Blockcerts to graduates, so they can find, immediately for use to be used for job applications. Next, we have the University of Bahrain is issuing diplomas as Blockcerts to the graduates. The system is part of a wider drive by the university to digitize its process and make ownership and portability easier for mobile and remote students. We have the Government of Canada Talent Cloud as part of a one-year project being co-developed by the Talent Cloud team and the Digital Identity Unit at the Treasury Board of Canada. Together with Learning Machine, the Government of Canada free agents will be issued Blockcerts. Then we have MIT, who developed this open source, open standard. They began issuing digital diplomas to a selected group of students, masters, PhDs, and the initial pilot project became full institutional rollout in 2018, with all MIT undergraduates and graduate students receiving digital diplomas as Blockcerts. Next, we have the Federation of State Medical Boards, which is a national non-profit representing across 70 medical boards of the United States and its territories. The FNCB also includes licensure and credentialing of medical practitioners. So they started sampling verification for undergraduate and graduate medical education credentials with Blockcerts. Next, we have the Caribbean Examinations Council, which is the premier provider globally that competitive curriculum that developed the services, examinations, certification, education services. They were relying on a paper-based, so they were committed on moving from paper to e-everything. So they started, the issuance took place on October 2018 when the CXC invited candidates from Barbados, Jamaica, and Trinidad and Tobago, and they received those advanced provision examinations as Blockcerts. Then we have Tecnológico de Monterrey, el Tec de Monterrey in Mexico. They issue diplomas to their students using Blockcerts. They will help all those students move around the globe and be able to verify their diploma's authenticity in seconds. Now we continue in Mexico. We have the Secretaría de Educación in Querétaro. In Mexico, there's a license that is issued by some of the different states once you graduate from a university. This license is called Cédula Profesional or Professional License. The Education Secretary in Querétaro is the first government to issue this professional license in Mexico as Blockcerts. And then we'll continue with Mexico. We have San Nicolás de la Garza municipio in Mexico. They are issuing alcohol licenses as Blockcerts. Being able to certify alcohol endorsements through blockchain technology allows to show a digital representation of a printed consent. And then we go to Argentina as one example. we have the first high school in the world to issue diplomas as Blockcerts to their students, and this is Belgrano Day School. And here's something I put together is a Blockcerts map. I would love to, if somebody wants to contribute or anything like that, I want to make this open source, of course. But here you can find the 4 companies that are building a solution to implement Blockcerts to make the adoption of Blockcerts bigger. But you also have who's issuing certifies different documents as Blockcerts. And here's the link that you can go into the map. Perfect, Anthony. You want to go ahead?
Cool. Thank you, Daniel. So yeah, I just wanted to go over like why Blockcerts, what are the pros and cons, why would you want to, why would you not want to? Blockcerts allows individuals to really own their own credentials and share them in a way that allows verifiers to prove that the certificates are valid, that they have not been tampered with, that they existed at a specific time, and that they were issued by the correct issuer. So basically everything that I've been really saying here today, open source, open standards, recipient ownership, verified existence, things like that, scalable, revocable, standard oriented, all really super big pros to why you would want to use it. Some of the cons, being able to adopt and support zero knowledge proofs would be great. That's not something we can do yet. So the whole certificate data is needed to verify a credential. It also requires a blockchain transaction to issue a batch. So for public networks, this is a concern. Of course, like I said, you can scale batches. I've done some scale tests, myself, and been able to issue thousands. But theoretically, there's not really a limit. It's really just an implementation limit of how many you can issue in a batch. Theoretically, it could be hundreds of thousands if you have the resources and availability to, theoretically. But still, it requires a cost for public blockchains. But this is what also really stands apart from Blockcerts from typical digital credentials, and when Blockcerts moves to verifiable credential standard, this is also what kind of not separates but extends the guarantees that verifiable credentials make. If we didn't anchor to a blockchain and we were just using verifiable credentials, if there was ever a problem with an issuer's key, maybe one was stolen, maybe they rotated their keys, maybe they revoked keys for various reasons, maybe an employee left and they still have the knowledge of the key, etc. Basically, you'd have to revoke every credential you ever issued with that key, since you cannot prove the dates in which the credential issued was actually valid. It could be many months later and someone issues a credential, but there's no, anyone can put whatever timestamp they want into the certificate itself. But what really proves that a credential existed at a certain period of time is by using a blockchain and is by using timestamps to help solve that problem. So yes, there is a public cost to issuing Blockcerts to public blockchains, but it's to provide this verifiable a proof of existence, basically. Also, there are some centralized points of failure with Blockcerts in V2. Issuer and revocation URLs are a concern, but in V3, we will be adopting decentralized identifiers, so we can mitigate some of those URL centralization points of failure concerns. And Daniel, I believe you wanted to say some things too.
Yeah, thank you, Anthony, for that. I think I'm going to quote something that a friend put together already in the past. A major reason why it's simple. How often do you get to do something that will bring immediately delight to people? Actually, we don't talk enough about joy when we talk about development. But one of the major features of the economy moving in a positive direction is that there are more and more things ordinary people can simply enjoy. These things make their lives easier, more fun, and more fulfilling. With easy shareability, instant verification, and recipient ownership. However, joy itself isn't enough. Above all, we need to think about the long-term impact. So here are some questions you should ask yourself. How easy is for my students or citizens to get a job? What steps does my students need to do to get the job outside or inside the country? What is the cost of printed diplomas or printed certificates? Are my citizens worried about getting a diploma or making them easier to move on the next step? You often need to present these multiple documents to get a job. I'm from Ecuador. I came to the United States to study, and it took me like 2 months to get a confirmation from the university that I'm okay to come to the US. So such as these certifications, such as degrees, transcripts, professional license, driver license, passport, national insurance card. Many people don't have one or more of these documents, or are overlooked for job opportunities, or don't even apply to begin with. That's a problem that can be easily fixed with Blockcerts. For a development standpoint, using Blockcerts also allows countries to leapfrog the digitalization process and go straight to the most secure, portable, and interpretable digital document. There is no need to duplicate work by digitizing everything in advance. Blockcerts can be issued by any institution wherever they are in the process of digitizing the records, even if everything is still on paper. And they can continue to use the legacy software infrastructure in which they already invested. By adding a few lines of code, already existing database can automate the verification and the screening of records at scale. Just one last thing is open standards, interoperability, rapid results, and not reinventing the wheel are all pretty good reasons to get behind these open standards. You want to continue, Anthony, with the next slide?
Yeah, thanks for that. So I talked a little bit about before, but version 3. So we have this big focus on aligning ourselves up with the verifiable credentials and decentralized identifier standards. That's going to be the main focus that we have on our roadmap. Some of the community members and I have been working on a draft for V3 since rebooting the Web of Trust in Prague last month, and so we'll be announcing a draft soon about some of the things that we're adopting, and some of the things that might change, and what it really means. So we'll get that draft out soon. We'll post it. It'll probably on community.blockcerts.org, and then maybe some of the email groups. We'd love some more eyes on it, get some feedback, get some contributions, schema suggestions, things like that. Learning Machine itself has also won a grant from the DHS to work on this effort, particularly the alignment of verifiable credentials and DIDs. So this is really huge, and we're really excited to just be able to upgrade Blockcerts to be more of an alignment with the rest of the verifiable credentials community groups that are pointing toward the same path. Besides that, besides any code contributions that people want to make for features that we're looking to add in V3, the big part of it is really just the adoption of the models itself. But there's always the nice to have of having more blockchains added to the mix. So anyone familiar enough with a certain blockchain shouldn't have too much trouble contributing. Feel free to reach out, post on the forums. We'll point you to the right directions. There'll be some programming knowledge, of course, Python and JavaScript, but those are typically simple enough. But yeah, next slide, Daniel. So I wanted to talk a little bit about verifiable credentials and decentralized identifiers before moving on. The verifiable credentials standard has been in the making for several years now, incubated by many of the members of the W3C credentials community group. Essentially, to put it in a very brief summary, it's a standard way to shape credentials and add proofs that allow someone to verify the integrity and ownership of them. They're capable of way more than that, but I want to be light on the description of it. But yeah, the W3C has given a proposed recommendation for the standard, which should actually go into effect as an official standard, I believe, very shortly, maybe within a couple of weeks, if there's no concerns with it. So that's amazing. A lot of hard work has been put into that. And then next slide, Daniel. To talk briefly about decentralized identifiers. They allow one to anchor an identity to a blockchain such that it is resolvable by anyone that has the identifier and has access to the blockchain it was anchored to. There's also some non-blockchain anchoring methods as well, and even some centralized DID method proposals. But the main advantage from DIDs really come from a globally resolvable public access way to resolve identities and any services that identities might be using. In terms of Blockcerts, this allows for the issuer profile to change from a central website URL to a DID that will always be resolvable. As long as that anchoring method exists still, which in the case of public blockchains like Bitcoin, I believe is way more resilient and lasts longer than a simple URL. So yeah, the DID working group charter has been officially approved by the W3C last month. So hopefully a lot of great work will be continued to come out of that. So I think that's all I had on that. But okay, cool. So that's the end. Yeah, thanks everyone. It's great. Thank you, Daniel and Alex, for putting this all together. And again, closing remarks from me. I'm always there on communities.blockcerts.org. It's a forum. You can go and post questions if you want to get involved. We also have our repositories, blockchain certificates. So yeah, if you want to get involved, feel free to reach out. Thanks for
Thank
joining.
you. Thank you, Anthony, for that. Alex, I just have a closing remark as well. The world. Yeah, go ahead.
Yeah, please go ahead. I mean, I have a couple of questions here in the pipeline, but maybe do your remarks and then we go to the questions.
Yeah, of course. So the world is changing. Students and workers, are more mobile. They are changing school, jobs, crossing borders, remotely working. The importance to provide these individuals with seamless way to translate their education and skills into opportunities, it's incredible, and it cannot be overstated. That's all, Alex.
Okay, awesome. Yeah, thank you so much. The number of questions that, especially John, one guy is participating today, and I also noted some questions, so I think we have a good number of questions. So if there any of those questions you cannot answer, or that then don't worry, or you can take them up in the future. I see that Bogdan is raising his hand. Bogdan, just please use the question tool. You just write them in, and I'll see them here on my dashboard, and I'll bring those questions up. Okay. All right. So just let me shoot with the first one. First question from John is: will Blockcerts support or run on the sovereign network?
Cool. So I think I can answer that. So I don't have the most technical detailed knowledge on the sovereign network, but I believe, like I kind of said before, as long as there is a mechanism for programmatic way, which I'm sure there is, to post a transaction, to write data into a field of the transaction, to look up that transaction and things like that. I don't see any reason why it wouldn't be able to run on any public or permissioned blockchain network. I guess if it's a permission one, the verifiers would have to live inside of the bounds of the network. So that may, however that is handled, I'm not sure, but I think it's definitely possible. I just don't know enough about sovereign to say definitively yes or no.
Okay. Just a question to clarify, just based on what you presented today, like the way I understand it, and correct me if I'm wrong, basically Blockcerts is a protocol, is a method that you can use to use different blockchains to register certificates, but the tool that is running on top to issue and verify, if you want to not have to build it yourself, that one of the providers who's doing that today is Learning Machine. Would that be a correct way to describe it?
I think maybe almost. I think that's a great way to describe it, but I would probably say, Blockcerts is more so the data model itself, and like you said, the way to the protocol for anchoring credentials and verifying them. But I would say that instead of that Learning Machine is like a provider for it. I would say that if people didn't want to build it themselves, actually, well, yes, Learning Machine can handle that, but our Blockcerts open source software can do a lot of stuff as well. It can do all the issuing, it can do all the verifying and things like that. To fit your exact needs, you may want to do some programming, you may want to import them as libraries, but as is, it's you can probably get up and ready and issuing your first credential using our open source software, in maybe like 30 minutes or less, as long as your like code environment configs are ready. So I'd say that like more so the Blockcerts open source software that's out there is more like one mechanism for issuing Blockcerts credentials, but it's mostly Blockcerts itself is kind of the standard open source, open standard like data model.
Got you. And there's another, just to keep on following with the questions, that will be a little bit mixed. I'm not structuring them to be like thematically correct. But the next question from John is, he's asking, does or will Blockcert support the standards and developing standards, verifiable credentials, DID, DID auth, DKMS? I mean, I think you brought up some of that, and I just would like add to that question. And again, it's just a perception. I might just be wrong. And I mean, I haven't seen really like Blockcerts people or people from Learning Machine in rerouting Web of Trust, IIW, or the Verifiable Credentials Working Group or the DID Working Group. Is it mostly because I just missed that, or is it just because you're collaborating but more remotely on those standards? Because I mean, the companies that I've been seeing most active in the Verifiable Credentials Working Group or the new DID Working Group is, I mean, especially Consensus and all its different flavors, like Uport, etc. The Sovereign guys, Digital Bazaar, Evenym, and there might be some other companies, but I mean, those are maybe the ones that I've seen like most actively represented in those events. What is the participation, and also mixing this with the question from Don of Blockcerts and Learning Machine on this whole setup?
Yeah, absolutely. I think it's a good question. Kim Duffy was pretty much the chief architect of this whole thing with MIT, and I don't know the exact dates, but she has been involved she's the co-chair of the W3C credentials community group. So I'd say, through her, we have a long history of being contributing to, the CCG and things like that. But yeah, besides just her, we have been, we're still a small startup, Learning Machine. So we send people every year to rebooting the Web of Trust and IIW. So we're there. We may not have the biggest presence there, but we're there, and we're contributing where we can, and especially with standards groups and things like that. So we're not the biggest presence, but we do participate.
Okay. Sorry.
Yeah, I think as the industry matures as well, you see other players, going to the IIW. I know Anthony was there. Some of the Xertify team was there as well. But yeah.
Great. Okay. So we have more questions here from John and also other people coming in. So I'll just continue with these as they come in. So what industries or use cases are the biggest users of Blockcerts? And can you give us a sense for how big, how many certificates, stay, verify, stay, etc. are being handled?
Well, thank you, John, for the question. The industry for the biggest users of Blockcerts is right now, universities, governments as well. Governments, using this for their universities, or like the Ministry of Education and Employment in Malta, the Government of Canada, the Secretaría of Educación in Querétaro. These are giving their students mobility or access to these, documents. Very simple, very easy to share. So that would be the biggest user of Blockcerts at this moment. How big? Any sense of how many certs per day or how many verifies per day? At the moment, I don't know that data with me on hand. I don't know if there's a way to check that. I'm not sure, but Anthony, I don't know if you have any input on that.
Yeah, so we don't run analytics on blockcerts.org or any specific thing, so we don't know how many people in the community have been issuing, and I am not sure what Learning Machine has publicized regarding
I don't
a
think
number
so.
of issuances, and I don't know if anyone else is really like the people that like organizations that are issuing on their own. I'm not sure if they publicized it either. So that's a good question, and I can't answer that right now.
Yeah, me either. Thank you, Anthony, for that.
Okay. Just as a follow-up question to this, I mean, my understanding is that like the original team that created this together with Kim Learning Machine is between MIT and Learning Machine. So, and that's one of the reasons why the main focus has been, the way I always understood this is like the education industry, like the issuing of. I understand it has been maybe growing beyond that, but that has been like the main core, right, of how Blockcerts has been used so far, right?
Yes, exactly. And I think also the fact that sorry, it is an open badge extension. A lot of open badges have typically been used mostly in the educational space as well. So I think that's another reason why it's also big in the education space. But yeah, exactly. We're trying to reach other industries and stuff like that.
And there is other industries, Alex. And I think this goes to the other question that Jen asked, but there is, like, for example, there is, like I said during the webinar, it was alcohol licenses in Mexico for the municipio de La Garza. You have that one. You have also, Anthony is actually the advisor at this company. It's called Truck.io. They are a logistic company and using, Blockcerts to issue credentials to drivers and for completed jobs. So you do see different industries getting into this open standard, seeing the benefits. But yeah, because the first push was education, and it is actually like a huge market still to take. You'll see more university, more other industries coming along as well.
Yeah. Just like talking about universities or like institutions, because most of the logos you had on your slides of use cases, they're more like conservative traditional industries. At least the way I perceive it, like you had many governments or government-related institutions, or some like education institutions, of course, which makes sense too. And what are the types of blockchains that they've been really using? And because right now, the way you're explaining it, the two main ones that seem to be available are Bitcoin and Ethereum. But from what I've seen in general, there's a certain reluctance from public institutions to use those blockchains, or at least to use them consciously. Are they all using Bitcoin or Ethereum, or are they using something else, or how have these implementations been done?
Yeah, so you want to go ahead, Anthony, or you want me to take this one?
Yeah, I can start off. So yeah, so Learning Machine uses our open source Blockcerts. I guess eat our own dog food, right? So right now we only have support for official support, in our blockchain repositories on GitHub for Bitcoin and Ethereum. So that's what we use solely. I think any of the there's only one known case of like a prototype where someone else was using a different blockchain. And I, like I described earlier, that was a university. I think it was a Columbian university actually, using it in Hyperledger. I think just as proof of concept. So any of the cases that I know about are all going to be Bitcoin and Ethereum. But again, there's no big reason why it can't be done on others. So any of the institutions and use cases I think Daniel showed, I think it's all going to be either Bitcoin or Ethereum.
Yeah, and from the research I've done and from the space I've been in, it's Bitcoin and Ethereum most of the times. Yeah, the university in Colombia, that was kind of like a research thing. They use Hyperledger, like Anthony said.
When you say Hyperledger, what flavor of Hyperledger are they using? Do you know?
I don't know that
I don't know.
they posted about it like a year ago, and it was just kind of like a video sample. Maybe it was indie. I don't know enough about that space to.
Yeah, no worries.
Um,
No worries.
Yeah, actually, in the map, I included a link to the information about that university. So if somebody wants to know more about it, they can click on the link there.
Awesome. Just one more question here from John, and then we have some other people also popping in, which is, do you see banks or commercial retail institutions getting interested in Blockcerts SSI?
Yeah, like I said, there is other industries already getting to know these Blockcerts, like truck.io, also the alcohol license in the municipio. You have there's a winery as well in Argentina using these Blockcerts, and there's other types. I know there is, but yeah, these are other industries that are
But no financial institutions so far.
No,
Because, I mean,
from the
I'm just
list
saying.
that no, I haven't seen that.
Okay.
probably not so far, but I think there's definitely use cases. Anything with sort of like I'd say like anything with a login system can basically be a verifiable credential authentication system instead. So, but also being like from a bank, being able to issue credentials that say maybe you pay on time all the time. If you're a bank or credit card company, or
Right.
that you have a certain amount of funds, maybe because you're about to buy a house or something. I definitely see the use cases, but yeah, I don't personally know of any active use cases in the bank and
Yeah.
or commercial or retail.
Yeah.
Okay.
That's right.
Okay. Next question is coming up from Jörg. Jörg is asking, do we have a performance issue if we write the hash of each certificate into the blockchain? And then he says, question mark, size of the blockchain.
So like I said before, if we're doing that single flow that I first described, where we do one at a time, definitely that is a concern. But through Merkle tree hashing, there's not that big a concern. You like for sure with our open source, you can do thousands, but theoretically, if you had a large enough disk space and large enough memory, that can exceed way beyond thousands. And you take that Merkle tree hash, and at the very end, so after hashing all the credentials together, you get one hash, and you use that hash, and you only put that onto the blockchain. So, theoretically, the sky's the limit what your compute resources can handle. But so there's not, as far as like blockchain implementation, there's not a limit at all, as long as I guess it can fit a 64 string character or something like that. You're good.
Awesome. Bohdan is asking how to solve the issue with the cost of. I mean, it's similar, but I just kind of read it out so that we make sure we read it out. How do we solve the issue with the cost of putting BCs on blockchain? So I'm not sure what BCs mean. Maybe you know. BCs on blockchain for use cases that require frequent and separate issuing of BCs. Maybe he means verifiable credentials. Any plans to
BC
support?
isn't Blockcerts. Blockcerts probably.
That's it. So okay. Any plans to support public Merkle tree services?
If you're referring to open timestamps, there's been talk about it as well. Some people in the community have asked about it. I don't. It is a way to be able to have someone else pay for your transactions. If you're using some other centralized service to do it, to do the anchoring for you. But I don't see it as I don't see it necessary due to how cheap and scalable the current implementation of Merkle tree hashing is with our open source software.
Okay, and then more related to performance, Jörg is asking, do we have a performance problem, number of transactions at the end of the study year when all examinations are finished and the badges are issued on the same day?
No, so so you can do, if you're doing it all on the same day and you have like thousands in the same day. Like I said, as far as like exact numbers, I don't have that for you because like a certificate could be very small or it can be really large depending on the HTML inside of it technically. But it like I don't have performance no exact hard numbers I can give you. But like I said, I personally using the same open source software tested thousands, but in a single batch, using just a single blockchain transaction. But really, as long as you have computer resources and memory, it can be further. But I don't have exact numbers.
Okay. Another question from Bogdan. Bogdan is asking, how does verification of issuer work? Do issuers need to keep the private keys on the server and sign challenges from verifiers? What happens if they lose the keys?
So I think the slide earlier that shows it better, but basically we have the issuer profile located right now as in a URL on a website, but in the future it'll be a DID. We just need to know their public key, so we don't need to know their private key if you're just a verifier. So as long as the public key matches the one that issued the transaction, you're good to go. So you can look up the issuer profile and see what they claim all their public keys are, and then you can check it. And our open source verifiers check that already, but you can manually check it if you wanted to.
Okay, and then here we have a final question from Jörg. I also have one or two questions left if you guys have time. Jörg is asking, how do you prevent creating a fake university and publishing valid certificate? I guess creating a fake university certificate and publishing valid certificates.
Yeah, exactly. So these are some of the cases where you definitely need to know, like for one, looking at the issuer URL. If the URL is pointing to some random web address, that's if they're claiming to be MIT and it's pointing to wordpress.org/fake MIT, then you know that it's not something that you can trust. As we start moving into verified credentials and using DIDs, this is where the problem gets really interesting because all we know is like a string of text, right? In the example of a DID, well, this is where maybe consortiums of maybe registries start popping up, maybe consortiums start popping up, maybe universities and verifiers just have to know the IDs, the DIDs of specific issuers, so they know, okay, if this DID is from XYZ, I know that belongs to MIT. But also there is also a new standard coming out called well-known DIDs. I believe that's the exact name of it. That the diff is creating so that you can have a way to publish all the DIDs that you control in a well-known address to kind of help this sort of registry problem. But but you're right. Someone could create a fake university and a fake URL and fake certificates that point to it. In this case, you need to know what that URL is and if it's what you're expecting. But as we move to DIDs, you're actually going to have to just know that what MIT's DID is.
Yeah, Anthony, I think there's, if I'm incorrect, there is also the public addresses registry for example, Malta, if I'm incorrect, where you can see the public address of all the institutions issuing it.
They publicly post that somewhere, so people can look that up. But yeah, so it would also be just a manual effort by whatever organization to make it well known what addresses that they are using, similar to the proposal standard for well-known DIDs.
Right. Thanks.
Just two small follow-up questions. In regards to verifiable credentials and DIDs, like the way you explained it, like my understanding is that until now, in reality, they were like not contemplated. Also, I mean, one of the reasons I guess is just because the standards were still being developed. But in this new project that you're working on with the Department of Homeland Security, I guess that's where you will integrate the vision about how verifiable credentials and DIDs might fit into the Blockcerts model. Is that correct, saying it that way?
Yeah. We personally wanted to take our time and make sure that we didn't want to start issuing live credentials that kind of looked like a verifiable credential, but because it wasn't standard yet, it's like a half implemented verifiable credential. So we started with, and I'm speaking in the past from before I even started, but yeah, we started with a standard, which was the open, a well-known standard, open badges. But now that verifiable credentials is becoming a standard, not only just us and governments like the DHS in Canada, they have their own initiatives where they're publicly funding. The government is publicly funding for verifiable credentials as well. Now it's becoming a standard. You're going to see a lot more organizations and a lot more adoption of verifiable credentials.
Great. And final question. I mean, I'm not sure if you might have seen this or not, but how would the vision of Microsoft Iron? I mean, it's not Iron; it's in reality a diff initiative, like a diff initiative with Iron, which is based on Cytree, which is also being implemented on Ethereum with Elements. How would that fit with what Blockcerts is doing?
I think it fits really well. So Blockcerts has always taken the agnostic approach, right? So agnostic to blockchains, agnostic to that. But we're also going to take the approach to agnostic to DID implementation. So if you wanted to create a DID on Transmute or a DID on Ion, you're free to do so. And there's like 30 right now. There's like 30 other DID methods, right? But I think like the vision of what Microsoft or sorry, the diff and then Transmute are trying to accomplish is scalable DIDs for everyone. And I think that incredibly lines up with how Blockcerts feels, especially implementing the Merkle tree issuing, right? We especially at Learning Machine, we want something that scales, right? We don't want something that it costs too much to do. It's too heavy and things like that. So I think their vision of what they're doing with Ion, we support and we have the same vision and same goals.
Great stuff. Awesome. So I think we've run out of all the questions. There were plenty of questions. Any final thoughts from you two that you would like to share?
For one, thank you for having me, and then thanks for everyone that showed up. These were great questions. I would like to, continue to be involved with everyone, the community. So, absolutely send me any more questions or go to the community. Community.blockcerts.org. We have sometimes a lot of times people get to questions before I even open the webpage sometimes. So we have a good community, and so feel free to participate. If something looks too heavy or you're not sure how to do something, if you want to contribute code, feel free to reach out, and I'll be happy to point you in the right places and get you started.
Yeah, I think from my side, thank you very much, Alex, for putting this together. Anthony, thank you very much for joining as well. If you have any questions or anything like that on the business side, just you have my Twitter. You can DM me. But yeah, it's a pleasure to be here, Alex.
Awesome. Thank you so much, guys, for helping us understand more about Blockcerts. For everyone else, we will be doing plenty of more SSI meetups in the coming weeks. I'm just still trying to fix the dates. I know that the 7th of November, we will have 3 box, which is split up from Newport, from the consensus group, talking about what they do at 3 box. But we also have plenty of other cool things coming up. Just trying to fix the right dates to make all that happen. If you want to be informed, please join the Telegram channel or use Twitter, Facebook, LinkedIn, and all of these other things we have to distribute when stuff is happening. I'll be uploading this chapter as soon as I can with the video, the Google Slides, and the slide share. And if you have any questions for Daniel or Anthony, you have their Twitter details here, or just reach out to me and I can maybe connect with them too. And so thank you so much, Daniel and Anthony, for making time, and it was great to have you. And I hope once you make more progress with Blockcerts and Learning Machine in the future, please ping me and we will be happy to share it so that people can keep on learning about it.
Thank you very much.
Yeah, thank you.
Awesome.
Yeah.